Algebra 1, Module 1, Lesson number 2 is the topic of variables. The objective of this lesson is to be able to write expressions from a verbal description and then also to evaluate expressions by substituting for a variable. So, to start off, what is a variable? A variable is a letter that represents a number. A letter that represents a number. So it could be like an X, Y, or Z, or A, B, C. Any letter can be a variable. This can represent different numbers at different times, but it represents the same number each place it appears in an expression. Now, let's talk about constants. What is a constant? To evaluate an expression containing a variable, such as an X, Y, or Z, you must be told what value to use for the variable. Then you substitute that number for the variable and evaluate the expression as before. Symbols such as 14, 7.8, 3/4, which stand for the same number all the time, are called constants. So a constant remains like what it says, constant. It doesn't change. Another term that you need to know for this lesson is called substituting. And to substitute means to replace a variable with a constant. Replacing a variable with a constant. You know, constants can be any number such as like a 3, say 158, 1001, etc. Now let's also discuss the terminology for what is meant by term. Terms are numbers that are added to each other or subtracted from each other. So numbers that are added to each other, such as 11 plus 3, that's an example of a term. Or numbers that are subtracted from each other, such as 11 minus 3, that's an example of a term. And then finally, let's talk about what is meant by factors. Factors are numbers that are multiplied together. So, for example, 11 times 3, that's a factor. What we'll learn a little bit later is, for example, 11 times 3 is 33. So we'll learn what is called factorization. And so factorization is when we break down and try to find possibilities. What times what equals 33? An example is 11 times 3 equals 33. So those are the factors. Okay, so those are the 5 terms that we need to know for this lesson. Now let's discuss the first example. Let's go over a first problem. Example problem. Say that we need to substitute 4 for x and evaluate this expression right here. 15 minus x times 3. So, let me walk you through how to do a problem like this. First, write down the given expression. So let's write down the given expression. 15 minus x times 3. And then it says substitute 4 for x. So we can say let x equals 4. So if x equals 4, then we substitute the 4 into the x. The 4 into the x. So as you can see, 15 minus x, or 15 minus 4, and then times 3. Now do the order of operations. 15 minus 4 is 11 times 3. So 11 times 3 is 33. And we double underline the answer. Now let's go over problem number 2. What if we substitute 9 for x? So let x equals 9 and evaluate this expression, parentheses 15 minus x close parentheses times 3. Well, let's start out by writing the expression 15 minus x parentheses close parentheses times 3. Let's substitute x equals 9, so the 9 goes in there. So let's substitute that. So that's 15 minus 9 times 3. Do the correct order of operation. 15 minus 9 is 6 times 3. That's 18. So those are 2 examples to start. Now, let's try a third problem. This problem will require us to examine and translate what is written in English into a mathematical expression. So to start, you will see or hear these 4 terms: sum, difference, product, and quotient. So if you see or hear the word sum, that means to simply add. If you see or hear the word difference, it means to subtract. If you see or hear the word product, it means to multiply. And if you see or hear the word quotient, it means to divide. So think of this as like a translation key. Mathematics is a language, and we're learning symbols and grammars and all these vocabulary words, and then we're going to try to understand and apply them in a mathematical situation and real world situation. Okay, so in problem number 3, let's look at the example 3a. It says the sum of x, 5, and 2. Let's go to our translation key to the right. The sum means plus, right? You add. So if the sum of x, 5, and 2, you're summing or adding x plus 5 plus 2. So that's a possible answer. The product of 2 and 11, so 3b. The product of 2 and 11. Let's go to the translation key to the upper right in our whiteboard. And product means multiply. So the product of 2 and 11 would be 2 times 11. 3C, I meant to write the difference 17 minus 4. I meant to write that in words. So the difference, as we look at the translation key, is subtract. So the difference of 17 and 14 is 17 minus 14. For 3D, the quotient, let's look at the translation key to the upper right. You see a division. So quotient means to divide. So if we do 13 divided by 7, you can write that as 13 divided by 7, or you could do it in a fraction form, 13 over 7. Now, it says x decreased by 6. Decrease, difference, same thing. Difference or decrease. So, it's decreasing, so it's a negative. So, if a variable x is decreased by 6, you're subtracting 6 from the variable x. More than is another way of saying the sum. And in our translation key in the upper right hand, what does the sum mean? The sum means to add. So, 10 more than y. Well, let's do this. The variable y, and then 10 more, also known as sum or add. So you add 10 more. So y plus 10. Less than. That's also another way of saying difference. And what is difference in the upper right hand corner? It means subtract. 50 less than x. So if we have a variable x, 50 less than x is subtracted by 50. So x minus 50 is how we translate 50 less than x, or the difference of 50 and x from x, or something like that. Okay, so that's we've done the third problem for this lesson. We have 2 more example problems to go through. Sometimes, as you can see in the fourth example, you see a picture, and an expression can be described by a picture. Before we had an expression described by variables or words. Now we have an expression described by a picture. And so let's look at this picture. It asks us find the length marked question mark right there, the question mark. Let me try it again. Question mark, okay? So to find the length of that whole length of that question mark, what does that equal to? So something plus something equals the question mark. So as you can see, there's a length x. We don't. It doesn't need to be specified. A variable or a number can work, or a value. So that x is a length and 7 is a length. So if we combine the two lengths, x and 7, x plus 7, the total length equals the question mark. So that's how we find the length. Now, let's look at the fifth problem. What if, again, find the length, mark the question mark. So here's the question mark. Notice the difference between example number 4 and example number 5. In example number 5, the question mark is part of one of two lengths. In question number 4, the question mark represents the total full length. So, to find the length marked x, what do we do? Well, let's try to translate it. So, since we know the whole length, 29, something plus something equals 29. Well, the first something is this question mark. The second something is this x. And then the total length is 29. If we want to find just the question mark, you may recall from your pre-algebra class where you have to subtract one of the numbers from both sides to isolate it into equal to one side. So in this case, you subtract x and you subtract x. So question mark equals, and then x minus x gets eliminated, and then 29 minus x. So question mark equals 29 minus x. Now, I want to point out one thing. 29 minus x is not equal to, or is not the same, as x minus 29. So if this was a test or a homework question and you wrote the answer to this was x minus 29, then you would be incorrect. So that concludes the second lesson in Module 2. Thank you very much.